vast universe, do other habitable worlds like Earth exist? This is a question that humanity has long pondered and is actively seeking to answer. In that effort, astronomers have discovered LP 791-18, an Earth-sized planet that also possesses a similar treasure, dangerous yet essential for life. That is volcanoes. On Earth, volcanoes are part of geological activity, and this entire geological activity is crucial for maintaining a stable atmosphere. The same goes for LP 791-18. It is an extreme planet tidally locked in its parent sun, but with signs indicating the existence of volcanoes, miracles could happen. This planet orbits a red dwarf star, about 86 light-years from Earth, in the southern constellation of Crater. Tidal locking means it always shows the same face to its parent star, similar to how the Moon is tidally locked to Earth. Thus, it has two sides, a day side and a night side, both of which could be covered by volcanoes. The research team led by astronomy professor Bjorn Anneke from the Institute for Research on Exoplanets in Montreal, Canada, and Dr. Jesse Christensen from NASA's Exoplanet Science Institute, who discovered volcanoes on LP 791-18, placed their hopes on the night side. LP 791-18 is a prime example of the influence of volcanoes on life. The day side might be too hot for liquid water to exist on the surface, while the night side can be too cold for life to thrive. However, thanks to volcanic activity across the planet, there could be areas with conditions favorable for life. First, volcanic activity on LP 791-18 could help maintain an atmosphere by releasing gases such as carbon dioxide, hydrogen, methane, and organic compounds. These gases could sustain the atmosphere and protect the planet from radiation from the parent star. The atmosphere could also reduce the temperature difference between the two sides of the planet. Second is the creation of water condensate. Volcanoes emit water vapor and organic compounds into the atmosphere. These substances could condense into water droplets or ice when encountering cold air on the night side. These water droplets or ice could fall to the surface and accumulate into ponds, lakes, or streams. Because on Earth, water is a crucial element for life and a solvent for biochemical reactions. Third is the provision of trace elements. Volcanoes spew minerals and trace elements essential for life from the depths, such as carbon, nitrogen, phosphorus, potassium, and iron. These elements could enrich the soil, seas, and support life on LP 791-18. LP 791-18 is the third planet identified in this particular star. The other two planets are about 20% and 2.5 times larger than Earth, respectively. All three were discovered by NASA's TESS telescope. Certainly, this planet will be studied thoroughly, as the connection between volcanoes and life remains a major and intriguing question in the field of astrobiology. In the journey of exploring the universe, humans have found many planets with potential for habitability. But to determine if a planet is habitable, what criteria do scientists rely on? One of the most important criteria is the distance to the parent star. A habitable planet must lie within a habitable zone of its parent star, where temperatures allow water to exist in liquid form on the surface. If the planet is too close to the parent star, water will evaporate and the atmosphere could be. If the planet is too far, water will freeze and life would struggle to develop. The habitable zone of each star depends on its luminosity and size. Another criterion is the atmosphere. A habitable planet must have a stable and suitable atmosphere to maintain temperature, pressure, while protecting the surface from radiation and meteorites. The atmosphere also provides elements and molecules necessary for life, such as oxygen, nitrogen, carbon, and water. A planet's atmosphere depends on its mass, temperature, and geological activity. Additionally, a habitable planet needs liquid water on the surface or beneath ice layers. Water is an important solvent for the chemical reactions of life. and an environment for organisms to move and exchange substances. Water also contributes to maintaining the atmosphere through its involvement in the water cycle and carbon. Additionally, water serves as a potential energy source for living organisms in areas lacking life, such as the deep sea or beneath ice layers. To have liquid water and a stable atmosphere, a habitable planet also requires seismic activity to maintain a magnetic field in the carbon cycle. The magnetic field acts as a crucial shield, protecting the planet from solar wind and cosmic radiation harmful to life. The carbon cycle is the process that regulates the amount of carbon in the atmosphere, oceans, and helping to stabilize temperature and maintain habitability. Seismic activity is sustained by heat from the planet's core, and tidal forces caused by other celestial bodies. Finally, an equally important criterion is the magnetic field. A habitable planet needs a magnetic field to protect its atmosphere and surface from solar wind, as well as cosmic radiation harmful to life. The magnetic field is generated by electric currents in the planet's metallic core as it rotates. The magnetic field also helps maintain ion balance in the atmosphere, a necessary condition for the existence of ozone, a substance that blocks cancer-causing ultraviolet rays. With these criteria, humans have discovered thousands of potentially habitable planets in the universe. Exploring the universe is one of humanity's great dreams. Thanks to advanced vehicles and technologies, we have achieved many notable accomplishments in searching for habitable worlds beyond Earth. These planets could become alternative homes for humanity in the future, when Earth no longer has sufficient conditions to sustain life. To date, the most promising exoplanets for humanity's second home are TRAPPIST-1e and Proxima Centauri b. TRAPPIST-1e is a rocky planet located in the habitable zone of the red dwarf star TRAPPIST-1. The star closest to Earth in the TRAPPIST system, about 39.5 light-years away from us. TRAPPIST-1e has a mass about 0.77 times and a radius about 0.92. This planet has an atmosphere, magnetic field, seismic activity, and may have liquid water beneath it. TRAPPIST-1e also has day-night and seasonal cycles similar to Earth. The average temperature on TRAPPIST-1e is minus 27 degrees Celsius, potentially ranging from minus 143 degrees Celsius. Proxima Centauri b is a rocky planet orbiting the star Proxima Centauri, the closest star to the Sun. Proxima Centauri b has a mass about 1.3 times that of Earth and lies within the habitable zone as hosts, where temperatures allow water to exist in liquid form on the surface. This planet has an orbital period of about 11.2 days and may be tidally locked, meaning one side always faces the star while the other remains in perpetual darkness. The average temperature on Proxima Centauri b has not been precisely determined, but it may range from minus 40 degrees Celsius to 30 degrees Celsius. It may also have an atmosphere and magnetic field to protect against stellar wind and cosmic radiation. Humans have not sent any probes to Proxima Centauri b due to its great distance, about 4.2 light-years away. According to some estimates, using current technology like NASA's New Horizons probe, it would take about 78,000 years to reach Proxima Centauri. If more advanced technology like the Breakthrough Starshot project is used, the time could be shortened to about 20 to 25 years. However, this technology still faces many difficulties and challenges to overcome. Sending a probe to Proxima Centauri b can be considered an extraordinary goal. Nevertheless, if humanity succeeds, it would be a milestone of great significance for human science. Subscribe to the Hidden_Realms channel to see the latest videos.